I'd like to welcome you to the BSE America location here in Charlotte, North Carolina. I'm Pete Hauser. We went ahead and we are doing a complete list as far as what materials you need to properly set your tools. We're also going to go ahead and find exactly how you take those measurements, how you upload those into the software on both the CAM software and the CNC itself. Then we're going to go ahead and we're going to start making a footprint. With that footprint, it's going to show us how we have to adjust those tools up or down. And we're also going to go ahead and show you how to put those polishers in properly without overpressure. Once we get those footprints created, we're going to go ahead and show you exactly those quality edges, so how you can maintain those edges as well. Then we're going to take some time and actually do an evaluation of a time study, how you can do a time study so you can figure out exactly how much that machine can produce for you. Okay, well, we're going to get a little bit closer. We're going to take an examination of this piece and see exactly what the tools are removing and how those tools are working. So starting off at the very beginning, this is our first pass that's showing with our Super Z. So that Super Z went ahead and removed the stock of the tool head of it. So this should be, essentially, this would be what is getting cut at the saw. So this would be a saw cut. On this particular example, it's still that Super Z as we trim the piece. So this is the position Super Z, position 1 profile, 2, 3, 4, 5 diamond, position 6 polish, and position 7 polish. So these polishers will increase that shine as the tools get broken into. One of the other things we want to go ahead and look at is underneath as far as that transition line goes. So as we break it through, we'll be able to see the transition that comes across each and every single tool. So once again, here we're coming back through. Right here we can see a nice transition for our position 5, our 6 polish, and coming over to our number 7 polish. So once again, we may see a little bit of gray at the very beginning as these break in. That will rub right out and we'll get a nice polish as it comes on. So back into here, it's very difficult, but we'll see where this transition line is here, it'll follow underneath the material as well. So it's very difficult to see. This is something more that you'll feel. Let's see exactly what our material thickness is that we're working with right now. Bringing it on the stone right now, we're sitting at 27.9 millimeter. Okay, I'm going to check a couple different spots just to see where we're at. Okay, 28, 27.9. Now as we go ahead and assess this, we can make any adjustments. The only thing that we will want to do right now is we may increase our 4th position up just a hair. Okay, it doesn't have to be much. I'm going to show you without making any adjustments to number 4, what would happen if we went ahead and ran the material thickness. So if we change the material thickness at 28, what that'll do to the machine and that program, and what it'll go ahead and do for a vertical offset, or how we can adjust all of those tools so we could do a vertical offset slightly down so we can still have an acceptable edge, but it'll encapsulate more of those common tools that you're using. All right, so what we're going to do next is we're going to go ahead and take a depth gauge and we're going to go ahead and verify those removals to make sure that they're within range. We're going to go ahead, bring this down on a flat surface, and we're going to go ahead and zero it out. Now we're going to go ahead and check to see how much removal we're doing with our Super Z on that first pass. So we want to be at about 1 millimeter. So right now we're at 1.02. This next step we want to be at 0.4. So right now we're sitting here, we're at about 0.5 millimeter. That could vary depending on where you're checking on the actual piece. So we're at 0.48. Next step here, we want to be at 0.3. So depending on where you're checking, we're at 0.35. We're about 0.31. So we're right in range. This should be 0.2, 0.24. 0.245, we're within range. This is going to be 0.1. It's going to be very difficult to see, but we'll go ahead and see where we're at. So we're at 0.08, 0.1. Now as we get down, we're going to be a little bit less. We should really be about 0.05. Now we're going to be a little bit harder to actually read that. So 0.09 is what it's reading. So we're doing a bare minimum removal all the way down. As you get going, you'll be able to feel exactly what you're looking for. So right now, we've got a nice start on where our tools are. Now we just want to go ahead and we want to break those in a little bit, and we'll let them run for a while. But as of what we want to do too is also show you a couple quick options as far as how we can make some adjustments with the Intermac machine on changing the material thickness height, and how we can go ahead and adjust these and drop them down. What we're also going to do is we're going to grab another piece of stone that's a little bit thicker so we can see exactly how these tools are working from top to bottom in that whole transition. We're going to do a trim sequence that's going to act just like as if we did a saw cut, and then we're going to go ahead and we're going to change the thickness of the material on the Intermac machine and see exactly how those tools automatically compensate down. When we went ahead and we took the mirror on the bottom side of the material, which is the polished side, we'll see that transition is going to be a lot less, so it's going to be a lot sharper edge. So right now what we're going to do is we're going to come over here, we're going to go to our program that we were creating our sequence, and what I have done is I added a trim at the very back, or the very end. So again, anytime I'm going to go ahead and do a trim, now I'm going to have different material thicknesses that I'm going to remove. So the stock removal is going to change as we go down. It's going to be less at the beginning and more towards the end. So what I'm going to do is I'm going to keep my hand under the control. I'm going to ease it into the material to make sure I didn't change a program incorrectly. And right now I'm just going to go ahead and run this about 40%. As I get towards the end, it's going to be a little bit higher removal rate. Still not reaching above 6 amps. So we're just going to go ahead and we're going to put material thickness at 28 millimeter, and we're going to see exactly how the tools automatically compensate depending on how the material thickness is. So setting everything back up, so we're able to go ahead and run this at 100% the entire way. Since we already verified the tools are set up properly on the original sequence pass, now we know that our programs are ready to go. So if we look at creating this footprint, we'll see exactly right here as far as what that length is going to encounter. It should be less than 5 minutes typically to do this footprint on this particular machine. It may be a little bit longer depending on what your tool changes are. If we want to look at how we could reduce those tool changes, we do have some options of being able to double stack your cones. So putting 2 tools on the same cone by getting a longer shaft for that cone. You'll have to go ahead and use higher pods as well. So going from a 150, which is typically standard in the industry, jumping up to a 180 or possibly a 200. 200 would be my suggestion as far as going that route. So once again, we're just creating this footprint right now so we can go ahead and evaluate how the tools drop down for a 28 millimeter thickness material on setting it on the machine. So as you calibrate the material at the machine, what that's going to do to the profile on the machine. And then we're also going to go back and we're going to go ahead and do a vertical offset for all tools so we can keep a consistent 30 millimeter always set to this machine anytime you're running 3cm material, so that way we reduce the amount of errors that could potentially come from somebody misreading the caliper or the caliper not being zeroed out properly. So what we want to do on a large production standpoint is set one thickness for that material, adjust your tooling exactly for that transition line from the polished side through the finish. So that way we're constantly getting a consistent transition line, so when you put your seams together, it lines up perfectly, reducing that handwork, because ultimately our goal is we want to finish 100% on the machine to reduce that labor at the end. So right now we're picking up our polish number 2. We're going to go ahead and see this is going to be sitting at that 1 to 2 amps. And when we go ahead and we break this in, typically I'd like to see that it's running about, I'd say anywhere from 10 feet to 20 feet would be considered pretty well broken in. And at that point, I'd go ahead and I'd reduce that amp draw to about 1 amp. So we'll reduce that abrasive thrust and we'll set it to 1 rather than setting it right now at 2. Okay, so now if we look down on the base side, I'm getting a little bit of a sharper edge. It's not as tight or not as rounded as the last. So what happened with this whole entire sequence, it has dropped down 1 millimeter. Since we went from 30 millimeter to 28, it takes half of that dimension and drops it down, so it centers that tool onto that particular thickness of the material. So if we thought about it, essentially, if we said this is our stone and this is our profile, typically you could go ahead and set it to where it's always setting like this. On an Intermac machine, when you put that height in, it's going to center it on the material. So if you can think as this is our material, this is our profile. So if I go ahead and I put this as my material, it's going to have the top and bottom exactly where it wants. If my material is thinner, if I leave it at the same, it's going to go ahead and locate it here. So if I had 30 millimeter and the tool was running here, and if I put a piece of 2 cm and I left the material thickness at 30 millimeter, it'll still come into the exact location. If I change the thickness to 20 mil, what's going to happen is it's going to drop this tool down and go dead center on it. So it'll give you an idea of how the tools are getting utilized in the software. All right, so now let's go in and take a closer look at this profile as far as where that transition line. We'll see that the transition line is not as far back in the stone, and the radius is not as fluent. So now we're going to have a lot sharper edge on the top side, which is the bottom side of the material that we're running. So at a quick glance, I can see now that our second position diamond is a little bit lower, since I can see a rogue diamond running through into position 1. Position 2 now cleans it up, 3 and 4. So we're getting rid of that line that transferred in. We're also seeing a little bit of gray residue from that polisher at the very end. That's just during that break-in period. So what we'll do is we'll run it a little bit further. If we go on the base side and we look at the profile, we can clearly see that now we do not have that radius going back as far. We're breaking the edge, but it's not as fluid. So this tooling right now, as far as the top and bottom is considered, it's about balance. So it's breaking both top and bottom. However, we're not getting that nice clean radius on the bottom side of it. So that transition line is much less in comparison of what it was. So what we can do now is we'll do a couple different things. If we look at this rogue diamond, since this is on the bottom side of the material and we know that it's going to get cleaned up, we could adjust it, or we could go ahead and try and dress it out. So we could dressing it out. What do I mean by that? We could go ahead and take one of the dressing stones and actually take a dressing stone on that particular tool to try to remove that rogue diamond. Or better yet, we can go ahead and allow it to actually run some production. Since this first position is actually doing the majority of the work on actually profiling the stone, it's going to wear faster than everything else. This second position typically is going to be able to clean up that first. So it's not transferring all the way down. So as we see, that line is gone. So we can take 2 steps or 3 different steps to it. 1, we can go ahead and dress it out. Number 2, we can go ahead and adjust it to where we raise that tool slightly up. Or 3, we can leave it alone and let production clean it out. As that tool runs, it'll go ahead and remove that diamond, and it'll go ahead and fix itself in the long run. So ultimately, I highly suggest that if you go with a route, you typically want to go ahead and try number 2 first. Try and bring that tool up slightly and allow for that second position to go ahead and clean it up. What we may want to look at on that is, what is that transition line? If we have a nice step on the base side, so if we don't have that nice step, then we know that we definitely have a rogue diamond. So if you can't feel a transition on the bottom side, that means we don't have any room to really bring that tool down to correct it. So what we're going to do right now is we're going to go ahead and we can make an adjustment on number 2. We're going to take number 2 diamond and we're going to slightly bring it up just a hair. Let's do 0.1 millimeter. So what we're going to do is we're going to take number 2, we're going to bring that up 0.1 millimeter. So bringing it up 1.1 millimeter should hopefully help take that out. And then we're going to go ahead and we're going to set these tools perfectly for 3 cm, and how we're going to adjust that is just by bringing all those tools up 0.5 millimeter from start to finish.